Alrighty. Hello, everyone. Welcome back to our monthly tech talk. Happy summer. I know it's been so lovely in Seattle. Hopefully, where you are is sunny and you get a lot of outdoor experience. Today, I'm super excited. We're going to talk about Three.js Fundamentals. And let me first start with a few words about our sponsor, the Collab Lab. So the Collab Lab is run by all by volunteers. We support early developers to gain real-world experience by working with other engineers. I believe our next cohort starts in August. So if you're interested in learning more, please go to our website or reach out to me. I'm happy to talk about it. Alrighty, then we are ready to introduce our guest speakers. I'm super excited to introduce Nathan Keys. Nathan Keys is a front-end web engineer with 8+ years in the creative and the tech industry. He has partnered with notable brands and organizations such as Accenture, Children's Hospital, Giant, and PenFed Credit Union. Currently, he works at Coforma as a software engineer and consults under his studio, Digital Anthro. Welcome, Nathan. I'll pass it to you so you can share your slides.
All right, thank you so much. All right, let me share really quickly. All right, so so welcome to Three.js Fundamentals. Um, Thank you, Yufa, for giving me this opportunity to talk. And you did a great background on me, so I might actually just skip my introduction. I will say a little bit more though. Uh, like you've said, my name is Nathan Keys. I front end web engineer, designer, and I also produce music as well. I am residing in Maryland. Um, and like she said, I'm freelance under freelance studio Digital Anthro LLC, where I specialize in front end development, creative development, and UI UX consulting. Um, I've had I've done some educating for George Washington University for their full stack coding boot camp. And I actually did this talk back in November while I was in Japan for a vacation. And for I did this talk at the Women Who Code, which was really cool because they were very excited about Three.js. So it was a really cool community. Unfortunately, Women Who Code disbanded, but they that specific branch kind of created their own other organization after that, which was pretty cool. All right, so you can't before I start, you can't see the your faces on the side of the screen, right? No? Okay. Okay, great. All right. So I'm gonna start with a few projects that I've worked on that I've used Three.js for over the past year. So the first one is Noise Shift Art Exhibit. I do a lot of art and kind of like experimental projects with Three.js. So this one was a visualization that I created with Three.js for a international call for artists for an exhibit out in South Korea. They displayed uh, this visualization within their museum for that exhibition during that time. I've also uh, created a website using Three.js, which allows users to generate art using a Perlin noise algorithm. If you've never heard of Perlin noise, is basically like is an algorithm developed by pretty sure it was developed by a computer engineer who works at Pixar. And they were trying to simulate how water moves in different kind of wave formations. So I use that algorithm in this website so users can kind of make variations of a 3D plane and print it off in JPEG format. And lastly, I created a audio visual music player with Three.js and shaders um, a couple of years ago for a project I had. And if you've ever heard of shaders, it's definitely a good extension once you learn more about Three.js. It's a great way to kind of enhance uh, your your experience or your project. Oops. All right, so we're going to so here's the agenda. First, we're going to talk about what Three.js is. Um, then we're going to look at how does it work. We're going to look at the documentation a little bit. Then we're going to look at how to create a scene. Then we're going to add 3D objects to that scene. We're going to take a look at the animation loop. Um, and conclusion, I'm going to show you a few Three.js add-ons that I find really useful and that might make the developer experience um, a lot easier. And they pretty much help you when it comes to working in 3D space because it can get a little out of hand, especially when you're doing a lot of um, camera movements or object movements and directions and stuff like that. All right, so here are the quick takeaways from this. Basic understanding of Three.js library, how to set up a Three.js scene, how to add Three.js objects, and lastly, the utility controls and performance tips. All right, so what is Three.js? So Three.js was developed in 2010 by Richard Cabello. Uh, it's a cross-browser JavaScript library used to create, render, and animate 3D computer graphics on the web. It was built on top of WebGL, which is a low level API for rendering web graphics. If you've never heard of WebGL, WebGL is a very low level graphics programming language that used to be used for, well, it used to be the probably like one of the only ways to render 3D objects in the browser. It is it's very complex and it takes a lot of code just to do something very simple like make a triangle. Yeah, just pretty much just like a triangle because you have to literally create the vertices and connect the vertices manually for the whole geometry. And so if you just think about doing a whole scene like that or a whole game, if not, it gets a little crazy, which is why Three.js really changed the game. It it supercharged the landscape of web design and web development due to the open source nature and due to it being significantly less complicated than WebGL. Some practical uses for it, you can use it uh, for data visualizations, geospatial maps, product customizers for e-commerce websites, web-based games, AR, VR experiences, and also medical and architectural modeling applications also use Three.js. All right, we are going to give the Three.js documentation a little bit of time. Let me see if I can switch over. Okay. And can you see the documentation page?
Yep.
Okay. All right, so not going to take too much time in here, but just going to highlight a few important points. So when you're starting with Three.js, there's very good getting started section just to kind of get the installation set up and look at some of the nuances of getting a project started. And the one thing I want to show you is the references section. So So in the Three.js documentation, so Three.js in the library, they have different types of classes. Those classes have constructors, and the constructors are the what we use to instantiate different objects onto into our scene. So um, for example, there's a class called a geometry class, or there's a class called a light class. And let's see, on the geometry class, we have different types of geometry. We have like box geometry, circle geometry, and you can kind of look through. It's really cool because the documentation like allows you to actually mess around with these objects before you bring them into your project. Um, and it actually shows you how to implement it as well. And also, this section here is very important because it shows you the different types of parameters that are associated with those constructors. So uh, when you're actually setting an object on your scene, you can come to the documentation and be like, oh, okay, here I can modify the width or I can modify the height. I can change the segments of which are like the triangle faces inside of the objects. So you can make a lot of changes to to your objects and I mean with so this is a really good reference for kind of like getting started and just figuring out what's out there. All right, so let's get into actually creating a scene. So if imagine like a play or like a musical, um, and let's think about like the essential parts that are needed to create a scene. I don't know musicals, so I picked Wicked, so like the closest thing to yeah. Um, so if you think about that, there's four main parts that create a scene, and it's the same way as in Three.js. So first you have your actual scene, which I mean in a play or musical, that would be your stage. The scene actually encompasses everything, like the cameras, the lighting, and objects. You have your light. The light obviously brings light to your scene and your objects, but also note that you can't, basically your scene is black without any type of lighting, or your objects are invisible without the type of lighting that you need. Next, you have your camera, which is just the way that you can it's the only way you can actually see your scene in the objects, and you can modify the camera to focus on different objects in your scene, and things like that. And then you have your objects, which would be your shapes, your models that you can import, and everything in your scene that you can that you would like to like animate. All right, and here's another little visual just to kind of see how it's set up. So if you think about you, like if you visualize yourself looking at your scene, your Three.js scene, you're looking through your camera. Your viewport is can be modified so you can kind of set like how far you can see into your scene, like the width of how wide you can see. So you can modify that. Inside of your scene, you have your objects, and then you have your light shining on your objects. All right, so we're going to switch over to CodePen, and we're going to kind of go through the steps to create this without the object first. So we're going to create the scene, and then we're going to go back and check out how to create the object. All right. And can you see my wallpaper or can you see CodePen?
Open.
CodePen. Okay, cool. All right. So the first thing that I want to, I can make this a little bigger. The first thing I want to highlight is is how Three.js renders into a project. Um, the first basically when when you're starting a project, Three.js renders a HTML canvas. That's like the final product. So you need to find a way to like append that. You basically need like an entry point to append that canvas to your HTML in that way. So here, right here, we have like a HTML element. Um, with an ID. And basically, when the scene is rendered, we are going to just do a document dot get element by ID and append the scene to the canvas. I mean, append the scene to the HTML element. All right, so all right, so let's see. So this is I'm gonna kind of go step by step. This is normally how I set up my projects. I usually start with a viewport, or you don't have to call it viewport, but it's just like a function to encapsulate all of your Three.js projects so that you can uh, just make things a little cleaner, and also so that you can put higher scope variables kind of up top, and you can use them wherever you want throughout different functions. Um, so right up here, I am setting like the scene, the light, camera, render, as well as the width and the height of the canvas that you see here. And I also created this function called an init function. You can call whatever you want, but this is the function that creates the scene. So we're going to take a quick look at code for this. This is the super basic code, but it's kind of like the boilerplate to kind of get started. So we start off with a scene. Um, and again, we Three.js has a constructor called scene that you can set. And it also has the scene constructor also has a parameter, or well, not parameter, but a property that you can use, that you can access to change the background color. If you do not change the background color, you get a black screen. That doesn't mean things are broken. That just means you need to kind of either add a background um, or if you want it to be black, you can keep it that way. Three.js also has a constructor for colors. So when you're adding a color to any property, you basically have to use this three dot color constructor in order to do that. The next step is we're going to set the camera. So there's different types of cameras. Perspective camera is one that you will probably be using like 90% of the time, because it's the camera that kind of has you look straight on into your scene. It's kind of like if you're watching TV or watching a movie or something like that. There's also other types of cameras, like where you're looking at it at like a bird's eye view, for example. So there's different orientations. I think most of the cameras actually have the same parameters. So I'm just going to go through these real quick. The first parameter is the field of view. is the is basically setting the area of which your viewport is showing. Next is you're going, and this is also a reason why we have the width and the height set up top, so we can basically use it in the initialize and in different functions. So the width and the height, width divided by height, this is showing the aspect ratio um, of the canvas. So that's needed for the perspective camera to be able to um, basically show the scene um, yeah, basically able to like show the scene in the entirety of the scene. The 0.01, so this parameter is the clipping, the near clipping plane. So these two are near clipping plane and far clipping plane. The near clipping plane should always be like a small number because it's basically saying that um it is the um see how to explain this, is basically the is as the closest that an object can get to the camera before it disappears. Um, so is a small number because you want your objects to be able, like if you want to have an object that's very close to your camera, you want to be able to do that without it kind of disappearing and you're like, where did it go? And then the far clipping plane is how far in your scene can your objects go without actually without disappearing. Um, so I hope that makes sense. But the main thing is to make the near clipping plane a small number, a very small number, and the far clipping plane a far number or a high number, so that you don't have to worry about wondering where your objects go because you have a a deeper um, viewport. All right. And and you can also set your camera position. Sometimes you don't have to do that. For the most part, you'll be setting your object's position. But there's certain times when you want to change the position of your camera. Um, you can use position dot set, which takes a vector three. This is X, Y, and Z. So you can modify the positioning based on that. And let's see, next we have the lighting. There are different types of lighting, different types of light constructors. This one is ambient light, which basically lights up the whole scene. There's also hemispheric light where you can pick two colors and the colors kind of gradient change from like one to the other. There's directional light where you can shine a light on like an object specifically. So there's different types of lighting with their own types of parameters, but again, that's where the documentation comes in handy. Um, and so after you set your light, you need to apply your light to the scene, and the scene has another property that you're probably going to be using a lot, which is add. So anytime you set a light or anytime you set an object, you have to add those to a scene. Next is a very important part, which is actually the render. WebGL has WebGL. 3JS has a constructor called WebGL renderer, which basically creates the canvas for you to append to your HTML. And let's see, and you'll also need to set the size. Again, you need to use this property in order to set the size for the canvas before it gets rendered. And then lastly, you do the document get element by ID. You get your canvas ID from up here, and you're appending that render. DOM element is a property that generates the canvas, the HTML canvas, and so that gets appended to your HTML element. All right, and so that's it for. I mean, that's it for the initialize function. Um, to go to the update function really quickly. Um, so the update function is also called the animation loop. Um, the animation loop basically it basically loops itself. I guess it would be recursive, possibly. Basically when you call the update function, you can actually call it different things in other this is kind of like a convention in a lot of different animation or computer graphics languages. So like P5 or processing, they have a similar like pattern. They use draw instead of update. But basically what we're doing here is we're calling request animation frame, which which repaints a frame in your browser, and then you're calling the function over again. But before you and after that, you're actually re-rendering the canvas. So you're basically making like a loop over and over again. You're updating the frame, you're re-rendering the canvas, updating the frame, re-rendering the canvas. And this function here actually allows you to add logic into it to basically like say for example, if you have an object and you want to move it around, you can add some logic into here that increments that object. And because the scene keeps rendering, um you that object starts to increment, or that object starts to rotate based on the incremental logic. All right. And so we're going to talk a little bit more about that, but we're going to jump into, oops, we're going to jump into actually creating the 3D object. All right. So, so there's three main parts of creating a 3D object. Um, there's the geometry. So in Three.js, geometries are composed of vertices, which are like coordinate points in 3D space, and faces, which are um, triangles. Like if you think about if you think about vertices, the vertice coordinates, if those coordinates they all connect into a triangle. And then that triangle is called a face. And the geometry is created by a whole bunch of those faces, whole bunch of those triangles. And that's kind of what I was saying about Three.js, when about WebGL, is you have to do all that manually, which is a headache probably. Um, but Three.js has many built-in geometries, but you can also create your own. We're not going to do that or talk about that really in this talk, but it actually makes it a lot easier to create your own geometries as well. The next part is materials. So materials are pretty cool. They define how the 3D object looks based on the type of material that you have. Um, uh, Based on that type of material, uh, it can be like a shiny material, it can be a matte material or metallic. You can also use UV mapping, which is taking textures and adding it to your objects. So there's a few built-in materials from Three.js. They all have different performance trade-offs. And based on what you want for your project, you kind of just weigh those options. And lastly, we have a mesh, which mesh is just made up of geometry and materials together. And so the mesh, if you can think about it, is pretty much just your 3D object, like the whole thing. So that's the thing that we're going to be rendering to the scene, and is also the thing that you can animate. You can animate geometry too, but that takes a little more effort and is a little more complex because you're modifying the vertices of the geometry. But with the mesh, you kind of just have to it makes 3GS makes it a lot easier to be able to modify that. And here's just like a short list of some of the geometries and materials. The mesh, we already talked about geometry, but the mesh standard material is the highest performance material. It kind of allows you to shine light on it and make effects like like reflective light, like metal, like metallic types of texture. Sorry, metallic types of textures. And uh, but the downside of that is it takes a lot of processing power. So, like I said before, it really depends on the type of project that you're trying to do. Mesh basic material is actually the least perform well, it's the most performant, but is the simplest type of material. All right, so we're going to get into creating the object. So the object should always be created in the initialize or the init function. And it should be always created after the scene is after the renderer. So we're gonna go into CodePen again. Oops. Okay. Yeah, so we're gonna go into CodePen. We're gonna check out how this object is rendering. So remember the rendering scene section. So this is where the scene is actually being, or yeah, the scene is being rendered, or the render is being set. So we want to add our geometry after that. So the first thing we're doing is we're creating a plane geometry. Like in the documentation, there was different types of geometry. Well, where there's a plane geometry where it's pretty much just like a flat surface. Um, some of the parameters are like width. You can change the width, like actually that might be a width or a height. Oops, not sure what happened there. That's weird. For some reason, I cannot edit this. But basically, this would be like the width. Um, this would be the height, and then there's also the um these last two ones allow you to um trying to think how to put it. It it gives it you can either increase or decrease the segments that are your geo inside of your geometry. So for example, and this is kind of more of a performance thing, if you have a sphere, for example, and you want to make your project very performant. You want it to work like load up fast, and you don't want to have any like performance issues. Then you try to cut down how many faces your geometry has. So how many like triangles are made up that are making up your geometry. So I guess the best way I can kind of think about or like put it is kind of like like you can have the more triangles you have in your geometry, the nicer, the smoother it looks. The less triangles you have in your geometry, the more it looks like Nintendo 64 graphics. Um, so the next part that we have is the material. So we can actually, so we have another constructor. We're using the mesh Fung material. Um, Fung is kind of like a computer graphics term. So you can actually look up the types of material and just kind of research like the names of them, and they all kind of they might come from actually different computer graphics um, engineers that might have even kind of invented that type of effect. But the mesh foam material takes a few objects. Actually, it takes or if it takes an object with um, I guess as many parameters as you want to modify. But for this specific material, I'm modifying the color, the wireframe, and the sides. The side is more of a performant thing. If you have when you're rotating an object, Three.js doesn't render the back of objects sometimes. Um, so if you were actually going to rotate it or show the back of it, for this instance, you would add the side and use the constructor double side, which basically allows Three.js to render the back. I think they might just do that because sometimes when you don't see the back, you don't really need to render it, and you're kind of it's helping performance. So we set up the material, and then lastly, we're going to use the mesh constructor, and we're going to pass in the geometry that we set and the material that we set. And then like the light, we still need to add it to the scene. Adding it is very for some reason I always forget to add things to the scene. So just remember that's the last step when you're trying to render something. All right, and uh that is pretty much how like your 3D object actually gets rendered. We're going to let's see, jump over. All right, we're going to talk about coordinates a little bit. So, so when your 3D object is rendered, um, um, and you want to, for example, move it around, kind of position it in a different part of your scene, um, you you have to kind of keep in mind that there's those X and Y and Z coordinates. Um, and when you can actually use a position, when you create your object, you can actually use the uh, the property position dot set, kind of like the same one we use for the camera. And it also takes an X, Y, and Z parameters, which you can use to move your objects to different parts of your scene. So little test here. Can anybody tell me where this object ends up on this coordinate screen? Yeah, 5 seconds. No kidding. Here's a little.
Question.
Oh, go ahead.
Sorry, is the order for the set parameters X, Y, Z?
Yes, yes. Probably should have made that clear.
So in the upper right, and then off up to the corner.
Like around here. Yeah, let's check it out. Yeah, you're definitely right. Yep, so like yeah, it's kind of it's a little jarring like when you start um kind of making the position changes. Honestly, kind of just experiment until you figure out where your objects. But great job. Yeah, it took me a while. Just say that. Um, and then all right, so last part, well, almost last part, but here's a quick rundown of the animation process. So in the animation loop, when a scene is rendered within the WebGL renderer, the animation loop calls the request animation frame, and it paints one frame. We use an update function or the animation loop to repaint the frame over and over again. And then we can also add logic to the animation or to the update function to kind of like create that um, uh, basically to animate your objects. And so in this example, we are using like a rotation property, and we're rotating the X and Y coordinates, and we're just incrementing by 0.05, which kind of creates that I guess kind of like spinning, rotating animation. And for conclusion, Um, here's a few like Three.js add-ons that are super helpful for me, and are would probably be helpful for you as well when it comes to navigating 3D like planes or 3D scenes. So the access helper would be a good thing to kind of like write down. It allows you to it basically puts an object like a kind of like an object in the middle of your screen, and it's just basically this, like it looks just like this, and it's a way to kind of see where the X coordinate is, where the Y coordinate is, and where the Z axis is. So that if your camera somehow flips upside down, or you do something crazy by mistake, you don't like you can easily kind of get back on track. Um, Orbit controls, that is basically a way to is a well, I guess it's an add-on. It's kind of like a plugin for Three.js, but you can use it to pan around your 3D uh throughout through sorry, throughout like the 3D space. Um, so you can pan, you can zoom in, you can kind of see like the whole 360 of your scene. And then the first person shooters or first person control is a it's kind of like a simulation of based off of first person shooter games where you're able to use your mouse or your trackpad to kind of walk through your 3D scene. That's what is going on here. And they also have different properties where you can kind of you can turn off the ability to look up and down. You can turn off the ability to nosedive into 3D space. I mean, so it comes in handy when you're especially when you're making games or like interactive experiences like this. And that is it. I will so also before before I end, I also have two demo projects that I don't know where I can post them, but I do want to share them with you so that you can kind of like the project that we just looked at, and then also this project, which is a little more complex, but it does show um it's kind of like a more enhanced version the other project where you can kind of see how like lights are being set. And you can see like the 3D, like the first person controls and how those work and things like that. Um, so yeah, and also here are some really good resources. If you really want to get into 3JS, I would recommend taking the Simon Bruno course. It's $95. It's kind of pricey, but is definitely worth it. Um, he covers everything, like absolutely everything. So I would definitely check that out if you really want to dive in. And then also there's this Nick Lever course, which is how I got started. So it's a pretty good starter course. And I have a article actually that that I wrote that was talking mainly about what we just talked about, which was how to create a scene. And that's it.
Thank you, Nathan.
You're welcome.
Yeah, send me all the links so I can share with the group. Thank you so much
Definitely,
for a lot of
definitely.
details. I know it's a lot to go through, and I feel like my brain is fried. But
Sorry.
no, no, this is not you. This is how things work, right? 3D rendering is complex because you have to think about X, Y, Z, right? It's
Yeah,
not doesn't really come naturally to think about.
definitely. And I mean, that's definitely why that's why I have those two demos because it like the boilerplate, getting those things set up. Once you memorize it, is a lot easier to just kind of pop in objects and just be able to mess around and move them around and things like that. So it gets a lot easier if that helps.
Yeah. I guess we have a minute, but since we started late,
Mm.
do we have any questions? Yeah. There's a shout out from Brittany. Um, she feel like your explanation were super clear. Agreed.
Thank you so much.
Thank you. I really enjoyed that. I'm excited to try it.
Oh yeah, definitely. Yeah, it's you can go pretty deep, but yeah, it's and the good thing is you can really get started and do really cool stuff like at like a basic level. Um and it still actually looks pretty cool. Yeah, even like the rotation cube, I know it's like you've probably seen it everywhere, but it's still cool when you do it. Um yeah.
No question? Yeah.
Everyone's brain is fried.
Yeah. Yeah. Haley is wondering if we can see your music project.
Oh gosh.
Do you use it with your music project? Oh, it's a
Oh,
different
do
question.
I
See
use
how
it?
fried my brain is.
Okay. I was like, good. Actually, I've done some music, like experimental music projects, but I haven't used it with music because I haven't performed yet anything. So it would be really cool to have like like the 80s demo scene type of thing and
Hmm.
just kind of do something with a backdrop. So maybe some point.
Thank you, Jessica. Okay. Any other question? Just one more question. Then we'll wrap this up. Cool. I guess we can end pretty much on time today. Thank you so much, Nathan. It's a lot of information and you made it really, I wouldn't say easy, but you made it really clear.
I appreciate it. That was one thing I was kind of worried about because I was like when I was working on it, I was like, this is a lot. Like I feel like I'm getting deeper and deeper into these. Yeah, but I'm glad everybody enjoyed it, and I hope you guys kind of experiment with it and just mess around with it because I mean, if you're into creative tech, or art, interactive art, things like that, you can really make some interesting stuff. And it's accessible because it's on the web.
Hmm. Well, I think that's a great conclusion. So we're gonna wrap it up with art. Thank you all. Thank you all.
All right. Thank you.
Thank you, Nathan.
Thank you.
Take care.